Hey guys, welcome back to another wonderful week of distance learning. Want to do a shout out to everybody I talked to on Tuesday. That was awesome. Okay, to see some of your faces in that, and especially in my 7-8 class where these are going to for this lesson and for the next lesson, because I'm going to do the next two for you. A little shout out to my boy Spanky for showing up, Allie, and even Evan's voice. Okay, it was good to hear you guys and see you guys. Hopefully we get more. Like I said, worst case, you don't have to join, but it's a chit-chat session. We can talk to each other, see each other, do whatever. Talk about, we did a lot of Netflix talking. What are we doing? What are we not doing? Binge watching, kind of that good stuff. So if you want to, great. If not, we hope you're all doing well and you're knocking it out. So let's get started. So we're on distance learning lesson 923 for day 1. Okay, and if you can see that we're doing square roots, and I have my square root here from my tree, which I know you're probably going, oh my God, seriously, Mr. McCarthy? Okay, on to the next one. So we got to have my bad dad joke. Okay, the question is for today, why do cow milking stools have only 3 legs? Because the cows have the udder. You know, like the udder one? Udder. Yeah. Okay. Yeah, let's move on. Yeah, I know, it's bad. But that's why they're called bad dad jokes. Okay, so here we go. So yes, we are. We're talking about square roots. Now, you guys already talked about the Pythagorean theorem. A squared plus b squared equals c squared. And I don't know if you learned in the video, but of all formulas that you ever learn in school, if you go ask somebody out in the real world, okay, what's one formula you remember about middle or high school about your math? The one that comes up the most often is a squared plus b squared equals c squared. Now, they might not tell you exactly how it's used in that, but that's the one that everybody remembers. And it's actually very useful. I've actually used it in my real life when I had to build a set of stairs, and you've got to get those angles for the stairs perfectly. And on this, being able to find the hypotenuse and then the 2 legs and working with that, I actually used the Pythagorean theorem. Okay, so it's kind of nice that way that we can actually use something that we learned in school and apply it to real life. So engineers, carpenters, things like that, don't be surprised if they say, yeah, they use it all the time. I know they use math all the time, but that they actually use formulas like that. Okay, so let's get this going. So we're understanding square roots. So how can I find a side length? So this is the point where we go, do we have enough information? So if you already know a triangle is a right triangle, check. How can the Pythagorean theorem help you determine the length of the leg or the hypotenuse? So today we're going to find a couple different ways to be able to do that. Okay, so first, let's talk down here at 980. Okay, 980 says Nikita wants to use the area of the squares in the figure to the right to find the lengths of the sides of a right triangle. Okay, so if we look at this, we have our right triangle. We have a square down below it, which is 16 units squared. The square off the hypotenuse, which is 20 units squared. You guys already have enough information, and you should have figured out from the prior lesson what this square is. But in case you forgot, let me give you a little, kind of a little boost here. Okay, so if we have the 2 legs here, you should be able to take the area of this, add it to the area of that, and it has to equal the area of the hypotenuse. Okay, so if this is 16, this is blank, and that's 20, what does that have to be? Good, thank you very much, Bella. So this has to be 4 units squared, because these 2 have to add up to be that one. So when it says find the missing area, we had 16 units squared plus x equals 20 units squared. And so we had to figure out that one, which for us at this level of math, there's not a whole lot to do other than that we know that 16 plus 4 is going to equal 20. Now, taking the next step, with this information, you should be able to tell me how long this is, how long that is, and how long that is. Okay, so when it says here, what are the lengths of the legs of the right triangle? So if this is 16 units squared, and it's a square, what do the side lengths have to be? Yes, Declan? Yep, okay. So he said this side's got to be 4 and this side's got to be 4, which means this length has to be 4 units. Then what does that side have to be over there? Go ahead. Okay, so that's 2 units. Perfect. Okay, so we have 4 units here. 4 times 4 is 16. 2 units here. 2 times 2 is 4. And then we should be able to use that. Remember, we have a squared plus b squared equals c squared. Now they didn't ask it for it, but if they wanted us to find the hypotenuse, all we would have to do is plug it in and do blank, 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 and be able to get this side length. Okay, by using the Pythagorean theorem. Okay, so let's go then on to C, where it says about how long is the hypotenuse. Are you able to find it exactly? So let's take that step. So what was the a squared? And I'll do it right down here so you can all see it. So we have a squared plus b squared equals c squared. We know that our a squared was 4 squared. Our b squared was, not 4 squared. Okay. Actually, yeah, we'll do it that way. 4 squared, and then over here we have our 2 squared equals c squared. So you had your 16 plus 4 equals c squared, or 20 is c squared. And that's where this comes from. This is c, and if we square it, it should be that number. The question is that a perfect square? And you should have said no to yourself. So can we find the length exactly? At this point, I might say maybe. Okay, so we're going to have to start using our detective skills to try to figure that out. And if you learned from the last unit, you should have known that I'm going to just take the square root of that. So most of you should be proficient enough if you grab your calculator, turn it on, and we hit the second button, we go there, hit 20, okay? 22nd, boom. Okay, my calculator's not working today. There we go, 20, boom. Okay, I might need to go get a new calculator, hang on. Okay, so this one's working. Okay, and you should see that we get a big number, 4.472135955. So we would round it off to the nearest tenth, so that would be approximately 4.5 units. Okay, and again, this is taking some review from the prior one and putting it to work here. Any questions? Okay, let's move on. Okay, here we have, now this relies on, I know I've been harping on my classes. I don't know about Miss Rodenkirk and Miss Warzen, but I'm sure they have. You guys should be proficient with your multiplication. You should know your multiplication tables. And when we say proficient, we're talking about that you should be able to do it through 15. If I ask you what 15 times 15 is, you should be able to tell me 225. Okay, things like that. So when we're talking about this, this is where a lot of that comes in. Because if you're having to sit there and do it on a calculator and struggle, while the rest of the class is moving on, you're still doing the stuff back here, the easy stuff, that's where you can kind of get lost. So this would be a good time, while you got extra time at home, to practice, get all those multiplication facts down all the way up through 15. If you can get them up through 20, awesome. Okay, but through 15, good. Okay, so here we go. 981, the numbers 36, 64, 4, 16, 100, 144, 121, and 225 are all examples of perfect squares. So if each of these numbers represents a number of square units in a square, what's the side length? Okay, so when we say a perfect square, so 36, okay, gives me a perfect square. So we've got to figure out what are the side lengths of those. Okay, that's what they're asking for us. So if I know this is 36, what should be the sides to get me there? Thank you for whoever yelled that out. So it'd be a 6 and a 6. Okay? What about 64 then? Yep, 8, 4, 2. What about 16? Good. 100? Anybody know 144 off the top of their head? Excellent, Allie. 12. Okay. What about 121? Emma, well done. And then what about 225? If you were paying attention, I gave you this one at the beginning. Okay. So those are our perfect squares. So why do you think they're called perfect squares? Well, if you think about a square and about a cube and how perfect they are. So if we have our square, okay, we have our cube. Let's do the inside. Okay, oop, my drawing's a little bit off. Let's fix that. Okay, when we say this is 36, if this is a 6, this is a 6, this is a 6, 6, 6, 6, 6, okay, all the way around, it's 6 times 6 to get the area of that. Okay, so I could say that, can I put, okay, 36 on each side? Because if I have 6 this way and 6 that way, I have 36 here, 36 here, 36 here. And then I could actually figure out the volume and how many cubes are in there, which would be really cool, but we're not talking about volume right now. So we have perfection right here. There's no 6 times 5 or 6 times 4. Okay, now let's put this to work. So if we want to find the side length of a square with a particular area, use the operation called the square root. So this is where our square roots are coming in. The square root symbol looks like this. Okay, it's also called a radical sign. So when you get up into higher math, they're going to ask you, what's under the radical sign. Okay, and the number that's under there, the radicand. So if we say this is the square root of 81, so we have 81 square units, that's what's in here. If I ask you to find the side, okay, now with the easy numbers, it's pretty easy. Most of you are going to yell out to me 9 times 9. But how it works is we take the square root of 81, okay, and since 9 times 9 is 81, the square root of 81 is 9. Okay, so if we know the area inside, I can just take the square root of it, and then I can find the outer edges. Again, perfect easy squares, it's easy. But we don't always get easy numbers, so let's try this. So this one, we get the square root of 49. So I need 2 numbers that when you multiply them together that are the same, that give us 49. Thank you, Lucas. So we have 7 times 7. Okay, so the square root of 49 is 7. Square root of 121. Thank you. This is how I know you were paying attention because we had this number earlier. Yes, that's 11. What about the square root of 9? So what 2 numbers multiplied together give us 9? Good. Anybody know 169 off the top of your head? Ooh, I've got a couple. All right. Go ahead, Connor. Yep, 13. Perfect. Okay, any questions on that? Pretty simple once you have it down. Okay, last little piece and then we're done with this one. Okay, can you make a perfect square with 24 tiles or not? So raise your hand if you can do it with 24 tiles. Ooh, I've got about 5 people that think they can pull it off. So let's find out. So we have 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So if I put 5 across here, I have 5 across there. Let's put this one right here. Let's put that one in right there. Let's put that one in right there. That only gives me 4 here and 4 there. So I don't have a perfect square. So why is it not possible? Because I'm missing a piece. Now be careful. Some people will jump up and say, well, then I guess it has to be an odd number. Not necessarily. Okay, so we're missing a piece. So they want us to estimate the side length of the square with an area of 24. So what two whole numbers is the length between? So they want us to estimate, okay, the length of a side of a square with an area of 24 square units. So we've got to estimate this. Well, what do we know already? What's the square root of 25 if it were 5 and 5? Okay, which is 5, good. Okay, so if we were looking for 25, it would be 5. What's the next perfect square down from that? Good, thank you. Someone yelled out 16, which is 4. So we're looking for the number 24. Okay, because it said, estimate the length of a side of a square with an area of 24 square units. So we've got to know, we know our numbers between 4 and 5 for the side lengths. Because if it was 5, it would be 5 times 5 and there'd be 25 of them. If it was 4, it'd be this, 4 times 4, which would be 16. But I need 24. First thing to ask yourself, is 24 closer to 25 or closer to 16? Good, it's closer to 25. So if I draw a line down the middle, that's 4.5, halfway. We know it's got to be between 4.5 and 5. Now this is where we start playing around with the numbers a little bit. And we start going, I want to get to the nearest tenth. Okay, so the square root of 24 is equal to what? Okay, we know it's between 4 and 5, and more specifically, we know it's between 4.5 and 5, because it's closer to the 25 than it is to the 16. And the halfway point between 16 and 25, okay, there's 9 units, so it'd be about 4.5, so this would be about 21.5, is only 4.5. So we know it's got to be closer. If it's me, since I'm really tight to the 25, I'm going to start playing around with numbers like 4.9 first, 4.8. So what I would do is I would get on my calculator, and I would go 4.9 times 4.9 equals, and I get 24.01. That's really close. So right now I could say approximately 4.9. Now, is it exact? No. Now, could I keep playing with this and go, can I get it to closer and closer? Sure. You could go, instead of 4.9, 4.89 times 4.89. Now I get 23.91, so I actually get a little farther away. So then I'm going to go the other side. 4.91 times 4.91. 4.91 times 4.91. Now that got me 24.108. So you could see we could keep going and going and going. But I'm pretty darn close at approximately 4.9. So you see how we can get it down to about the nearest tenth? Okay, and since I'm just over, it is probably somewhere in the ballpark of like 4.8999. Okay, because I'm just a little bit off. But we only need it to the nearest tenth. Think you can do that? Okay, let's give some practice. Okay, so what I want you to do right now is to take about 2-3 minutes. What's the square root of 225, 289, and then 108? So pause the video right now, and let's see if you can do that. Okay, now that you're back, so hopefully you got me the square roots of 225, 289, and 108. So 225 should have been your easy one for sure, because we've already done that one. You should have gotten 15. 289 is also a fairly easy one. Hopefully you got 17. 108 is the one that I kind of threw you for a loop, okay, that you'd have to play around with. So hopefully you said the square root of 100 is 10, Okay, we go up just from there. Square root of 121 is 11. Okay, I'm closer to 100 than I am to 121. So it's got to be between 10 and 10.5. So then you hopefully started playing around with those numbers. Okay, and if you read the directions, it says always round to the nearest tenth. You should have gotten about 10.4. Okay, questions? Awesome. Have a good day. We'll see you for tomorrow's lesson, or actually the next one after this, which is day 2. Rock it.